Hello, good morning. CAMs, once again, second lesson of CAMs. A recap of first lesson. In the last lesson, we had discussed about CAMs, applications of CAMs, types of CAMs, types of followers. These four we have discussed in the previous lesson. Today, in this lesson, the objectives are on completion of this lesson, you would be able to learn working principle of radial cams, working principle of cylindrical cams, nomenclature of radial cam, so let us see the working principle of radial cams. As we have discussed in the previous lesson, radial cams are also called as cams, and the radial cams are two types: circular cams and tangential cams. So the working principle in this is, and here used to transfer circular motion of the cam or rotary motion of the cam into reciprocating or oscillating motion of the follower. Cam rotates about its center, and its radial distance varies from the center. Cam rotates about its own center and its radial distance varies from the center to the outer surface. And this variation in the radial distances will provide a rise and fall of the follower during the cam rotation. The cam's followers may be arranged in different combinations. That means with the radial cam, it may have knife edge follower, it may have roller follower, it may have flat follower, or it may have spherical follower. That means it may be of different combinations. But the motion of the follower depends on only upon the profile of the cam. The motion of the follower depends upon the profile of the cam. If the profile of the cam changes, the motion of the follower also changes. That means the motion of the follower is not depending on whether it is the whether it is the knife edge follower, roller follower, or flat follower, or spherical follower, but only it is depending on the shape of the profile of the cam only. Here you can see this is the shape, outside surface shape of the cam. This is the radial cam, and this is the minimum diameter, and here it is the axis, and this cam is going to rotate about this axis, which is perpendicular to the cam plate or the disc, and here is the follower, which is having a flat surface, and this surface may be the follower, may be either the knife edged follower or the roller follower, or as it is shown in this figure, it may be the flat follower also. And the motion of the follower is not depending on whether it is knife edged roller or flat follower, but the motion of the follower mainly depends on the shape of the follower. And from the center, the radial distance at this position is high, whereas at this position is very low. That means this will be the minimum. So due to this variation in the radial distance, there is a possibility of rising and falling off, lowering of the follower takes place. That means this may have, due to this may be having either the reciprocating or oscillating, whatever it is, right? So this is all about this is the cam and the camshaft, and this is the follower, and this is the guide frame. This is the guide frame, and this is the surface or the profile of the cam. So here you can see offset follower, radial cams, offset radial cams. Here means offset means this is the axis which is perpendicular, axis of the cam which is perpendicular to its surface, cam surface, and this is the axis of the follower. In the previous figure, this axis of the follower as well as the axis of the center of the cam is in the same line. But whereas in this, it is just away from the center of the cam is away from the axis of the follower with a distance of E. So this will be the E, maybe offset. This is called offset. That's why it is called offset radial cams. So this is all about the working principle. Simply once again, I will explain. This cam is going to rotate about the axis perpendicular to it, the surface of the cam, and the follower either reciprocates or oscillates about its axis of the follower, and due to the shape of the cam, the follower motion depends, and this follower always in touch with the in touch with the cam profile, cam surface. So this is the simple working principle, and this follower remains in touch with the cam profile or cam surface by means of either gravitational force or the spring force. So this is the working of radial cams. And now let us see the working principle of cylindrical cam. Working principle of cylindrical cam. So the rotational motion of the cam causes the motion of the follower along the groove of the cam. The rotational motion, cylindrical cam motion of the rotational motion of the cylindrical cam causes the motion of the follower along the groove of the cam. This provides reciprocating or oscillating motion to the follower. If you see, this is the cam which is having a groove in which the follower is in contact with this groove, and it is the follower which will oscillate parallel to the axis, which will reciprocate parallel to the axis of the cam, cylindrical cam. So as it is rotating about its own axis, and this cam will move along the path of the groove cut on the surface of the cam, due to the rotation of the cam, the follower may move, have reciprocating motion parallel to the axis. Here in this also, it is going to oscillate due to motion of the follower along the groove. So this is all about the working principle of cylindrical cam. Now let us see the nomenclature. Nomenclature of the cam. Here you can see this is the radial cam. This is the radial cam and the roller follower, and this is the guide frame. If you see various points here in this nomenclature, you can see many of the definitions. One is the base circle, prime circle, pitch circle, cam profile, pitch curve, tangent, pitch point, direction of motion, pressure angle, and normal, follower, trace point, cam angles. So let us define one by one term of nomenclature. So base circle. Here is the base circle. This is the base circle. This will be the base circle. It is the smallest circle. It is the smallest circle. If you see, the smallest circle that can be drawn to the cam profile. That means this is the profile, and for this profile, this will be the smallest circle. This will be the smallest circle, which is the small radius, this much of radius. If you go on other places, this will be the more, this radial distance will be more. If you see, it is maximum. And if you see here also, only from this to this point, this is the smallest radius and also smallest diameter. So if you draw with this radius or with this diameter, smallest diameter, with the cam center, then it is the base circle. The smallest circle that can be drawn to the cam profile from the center of cam is called base circle. This will be the base circle, right? Next, prime circle. So if you see, this is the smallest circle of the cam profile, and there is one point in the follower, and this point, say this is the point of the follower. So in this roller follower, this will rotate about its own axis, and it will be in touch with this cam profile. And from here to here is the distance to this point and here. And if you take a circle, smallest distance, maybe this much is the smallest distance for this curve, and this point is called a trace point. And if you draw from this to this, if we have this radius, draw a circle that is called prime circle. So let us see the smallest circle drawn to the pitch curve. This will be the pitch curve. So the smallest circle drawn to the pitch curve from the center of cam center of rotation of the cam. That means this is the pitch curve, this will be the smallest radius, and this is the smallest diameter. If you draw a circle with the smallest radius or smallest diameter, that will give you the prime circle. If you see here, this roller follower, it is clearly defined, the prime circle is clearly defined, and pitch curve is different from the cam profile. Whereas in case of flat follower or it is knife edge follower, this circle is not there, because this point of trace, this trace point remains in touch with the cam profile. That's why the prime circle itself is the base circle in case of knife edge follower and flat followers or mushroom follower. Whereas only in case of roller follower, prime circle is different from the base circle, right? Next, pitch point. This will be the pitch point. This will be the pitch point. A point on the pitch curve. This will be the pitch curve. On this pitch curve, having the maximum pressure angle. It is the, if you take this will be the pressure angle. If it is maximum, then this point on this pitch curve is called pitch point, right? And pitch circle. So if you draw a circle passing through this pitch point, say this is the pitch circle, this will be called as pitch circle. If you draw with a radius of center of cam to the pitch point, draw a circle with a radius of from center of cam to the pitch point, then it is called pitch circle. Let us have a circle drawn through the center and the pitch point. Is the pitch circle, right? So this will be the pitch circle. First one is the prime circle. This is the cam shaft, base circle, prime circle, and pitch circle. And this is the trace point, and this is the pitch point. And this point where it is the point on the follower, which is in touch with the cam profile. That is trace point, and this is the point at which the pressure angle is maximum. Pitch curve. The curve generated by the trace point. This is the trace point. This curve is generated by this trace point. As the follower moves relative to the cam, the curve generated by the trace point. As the follower moves relative to the cam. This is called pitch curve. Cam angle. The angle turned or angle rotated through by the cam from initial position. Angle rotated or angle turned through by the cam from the initial position. Say maybe this is the initial position, and if it is turned to this point, this will be the cam angle. And the cam angles are of three types. One is the angle of ascent, when the follower is at the highest position, angle rotated by the cam from lowest position to the highest position of the follower. And the angle of descent, when the cam is moving, when the follower is moving from topmost position to the lowermost position due to the rotation of the cam. And angle of well, when it is the angle rotated by the cam during its stationary period. These are the three types of cam angles. Trace point, a reference point on the follower. Here is the reference point. Here is the reference point of the follower about which the roller is rotating. In case of knife edge follower, the knife edge point itself is the reference point, which is called a trace point. In case of flat follower or mushroom follower, if it is the midpoint of the follower, that is the reference point on the follower, are called trace point. And this trace point is used to generate pitch curve. This trace point, that means indirectly the pitch point is also trace point, but at pitch point the pressure angle will be maximum, right? So in the case of knife edge follower, it is the knife edge. That means trace point is the knife edge. And in case of roller follower, it is the center of the roller. This is the center of the roller, that is the trace point. In case of knife edge itself is the trace point. Pressure angle. The angle between the direction of the follower, this may be the direction of the follower, and a normal to the pitch curve. If you draw a tangent to this pitch curve, this is, and this will be the normal to the, this is the normal to the pitch curve, and the angle between the direction of the follower and this normal is called pressure angle. And it is very important in designing cam profile. If it is too large, a translating follower will jam in its bearing. Pressure angle, the angle between the direction of the follower and a normal to the pitch curve. If you see here, this is the pitch curve passing through the trace point, and this is the point at which this pressure angle is maximum, and this angle, this is the direction of the follower, and whereas this is the tangent, for this tangent this is the normal, and the angle between this normal and this direction of the follower is called pressure angle, right? So this angle is very important in designing cam profile. If it is too large, a translating follower will jam in its bearing. Now the lift, the term lift, the maximum travel of the follower from the lowest position to the topmost position, from the lowest position to the topmost position. That means if you see here, this is at the lowest position. If here is the lowest position from here to here, because it is the minimum radius of the cam profile as it is touching with this. If from here to here, if the roller is at this position, from here to here distance, if you see, this will be the travel of the follower. That means from A to B is the travel of the follower. That is called lift, or also called this as throw, or also called this as stroke. That means if you call it as lift, or if you call it as throw, or if you call it as stroke, is same. So simply in this figure, A to B is the lift or throw or stroke. Now this is all about the nomenclature. As you see, first of all, base circle, which is the smallest circle drawn for the cam profile, from cam center to the cam profile, this much. And the prime circle, it is the smallest circle drawn from cam center to the pitch curve, and the pitch circle is the smallest circle drawn from cam center to the pitch point. And then cam profile, it is the surface of the cam through in which the follower always remains in contact with the surface. And pitch curve, it is the path traced by the trace point for the cam profile, and it is the pitch point is, it is the point, it is a point on pitch curve at which the pressure angle is maximum, and the trace point is the reference point on the follower. In case of roller follower, center of the roller is the trace point. In the knife edge follower as well as flat follower, it is the point, or in case of flat follower, it is the middle point, right? It is the trace point. So next is lift, it is the maximum travel, and the angle, pressure angle, is the angle between the direction of the follower and normal of the pitch curve. And next is pressure and cam angles, it is angle through which the cam is rotating to raise the follower, is the angle of ascent or the cam angle ascent. And if the angle through which the cam rotating during the fall of the follower is called angle of return or angle of fall, you can see. And the angle through which the cam is rotating during the stationary period of the follower is called dwell. So this is the information, that is the nomenclature of, once again, base circle, prime circle, pitch circle, cam profile, pitch curve, pitch point, pressure angle, cam angle, trace point, lift are the nomenclature of cam. Now cam profiles for plate cam or disc cam, you can say. The cam profiles can be drawn by using displacement diagram. That means in order to draw the cam profile, the displacement diagram should be there, which this displacement diagrams will be discussed in the next lesson. Right? The following information is required to draw cam profile. In order to draw the cam profile, we must have the displacement diagram and also the following information. Number one, the type of follower and its desired motion. That means type of follower means it may be the knife edge follower, it may be the roller follower, or it may be the flat follower or mushroom follower. And its desired motion may be also different for each type of follower, and it may be different type of motion. And the total rise of the follower, that means total rise of the follower is nothing but the lift or stroke or throw of the follower. And the base circle diameter. Base circle diameter means in order to draw the base circle, that means this, it is the smallest diameter of the cam profile. And also the direction of rotation. That means if it is rotating in which direction. And the cam angles, that means angular displacement of the cam. The cam angles means angle of ascent, angle of descent, or angle of outward stroke, and return stroke angles, and dwell angles also we should have. So this is the information that required to draw the cam profile. Number one, displacement diagram is required, type of follower is required, motion of the follower is required, total rise of the follower is required, base circle diameter is required, direction of rotation of the cam is required, and also angular displacement or cam angles are also required to draw the cam profile. And here some assumptions are there. Number one, only one assumption made to draw the cam profile. While drawing a cam profile, it is assumed that the cam is stationary. To draw the cam profile, let us assume the cam is stationary and follower only moves around the cam profile in a direction opposite to the direction of the cam rotation. In a direction opposite to the around it in a direction opposite to the given direction of the cam. So this is the assumption that we are going to, after taking this assumption, we are going to draw the cam profile. So this is all about the working principle of radial cam and the working principle of cylindrical cam, and the nomenclature, and also information required to draw the cam profile, and also assumption made to draw the cam profile. So far we have discussed in this lesson. Let us see the summary. We have discussed the working principle of radial cam, working principle of cylindrical cam, nomenclature of cam, and cam profile of disc cam. And now let us have a small quiz. Motion of the follower depends upon material of the cam, material of the follower, profile of the cam, none of the above. If you see, material is not the important to draw to have a different desired motion of the follower, and the material of the follower is also not important, but only the profile of the cam will give the desired motion to the follower. That's why C should be the right answer. Right? C is the right answer. Radial cams are used to convert rotary motion into reciprocating motion, rotary motion into oscillating motion. A and B, none of the above. So actually, the radial cam rotates about its own axis, and the follower may have reciprocating motion or sometimes oscillating motion also. Right. So A and B must be the right answer, but A is not right answer. This is wrong answer. The maximum travel of the follower from the lowest position to the topmost position is called as lift, throw, stroke, all the above. Which is the right answer? The maximum travel of the follower from lowest position to the highest position. This distance is called also lift, also throw, also stroke. So all the above should be the right answer. Let us see this answer. All the above is the right answer. Next, the circle drawn through the cam center and pitch point. The circle drawn through the cam center and the pitch point is called base circle, prime circle, pitch circle, roller circle. Which is the right answer in this? So base circle is not right, prime circle is also not correct, roller circle is not correct. Which circle should be the answer? Let us see. Right? So C should be the C is the right answer. Which of the following information is required to draw a cam profile? The type of follower and its desired motion, the total raise of follower, the base circle diameter, all the above information is required. Which is the right answer? Once again, which of the following information is required to draw a cam profile? The type of follower and its desired motion, the total raise of follower, the base circle diameter, and all the above information. As per my knowledge, total 3 are required, so 4 will be the answer. Right? All the above information is required to draw the cam profile. Thank you, friends. With this, we concluded this lesson. Okay.